So let's move on to symbolic links. Symbolic links are called soft links or symlinks. They are pointers to other files or directories that are called the target. They are useful for several reasons. They are both in order to avoid giving a long path each time you change to a directory, like your project directory. So you just have a shortcut. And it's also in order to avoid changing hard links within other scripts or programs. Or for instance, you install a program or a script and it assumes that you have a library that is called libcoolness.a, for instance, and not libcoolness.2.0.a. It's very common that when you install a new library or something, it will have a version number or something. And then you just point from what the program expects to what you actually have there. And that means in the future you just update the symlink instead of renaming the library or updating the perhaps many instances where it's mentioned in the program. So it's definitely a safer way of doing it and easier. You may have heard symbolic links called soft links. So what's a hard link? They are also shortcuts for files, but not for directories. But a hard link cannot be created for a file in a different file system. So a syntax for a soft link or symbolic link, you create it with ln-s, the real file folder or library, and then whatever you want to name the link name. And a hard link, you would do just ln, the source file, to the linked file. And to check a soft or hard link, you can run ls-l on the source and the link. If you want to just have some files to play with, you can use any in this exercises directory. It doesn't really matter. So I will go fairly fast over this, but I would suggest that you either code along or do this afterwards also. But I'm going to work in this redirect and link directory. And you can also just create a test file. And for instance, we do it the same way as we have done several times now today. This is the content of my test file. And redirect it to a file called test file. So now we have a file, test file here. And if I wanted to create a hard link to this file here, then I do it with ln test file, and I could just call it link file. Ln test file and link file. Let's try and see what we have. And we can just see if this is correct. And you can now see here with -i, we can see that they are identical. This is the inode. That is what I'm asking for with I here. And inode, so index node, is something that we have in Linux or Unix, and each object in a file system is represented by an inode. It's a data structure. It stores basic info about files, directories, and other file system objects, and you can read more about them if you want to. But you can, if it has the same inode, then it is the same file. So what about the soft links? Well, we could create one in our home directory. because maybe we feel this is a long link here, intermediate bash exercises redirect. That is a long text to write each time. So let me create a soft link. And then I am taking this long line here. This is the path. And then I'm putting it in $home. And then I will just say my excess, because I already have one that I called my exa. And then in my home directory, which has a lot of stuff, then somewhere I have the exa one. It's probably not that far up there. I called it my exercise. Okay, here. So you see that it points to this directory we have here. And that was what we had here. So if you want to create a symbolic link to a file in the same directory as the file, because maybe you wanted to do that, and just call it something else. And that's what you might want to do if you had the library situation, where you wanted it to have the name that you expected instead of the one that it actually had. And here I did create, to play with this file that we are now going to rename, so that our imaginary program can actually find it. And then I am going to give the same long path here again. But I'm going to just call it what I expected. So now that is here as well, and you can see it is in, for my shell, it is marked in a different color because I added stuff to my bash RC, so it makes the files differently colored if they are executable or if they are links or whatever. You may or may not have something like that set up, but in any case, here you can see it now points to this file here, and that means that when your program references this file, libcoolness.a, or this library, then it finds it and it grabs what is in this one. So this is an easy way of doing that. And you can also do it in a different directory, of course. If, say, you had some libraries for 64-bit that are installed in the 64-bit library, but your program doesn't want to look there, it wants to look in the regular user lib, then you just create a symbolic link in that directory with the same name as the one that it actually has, and then link those two together the exact same way. To remove a symbolic link, you can do it with unlink, or you can just remove it like you would remove a file. You can, if you use remove, you can remove multiple symlinks at once. And yeah, it's just remove like any file. When removing a symlink to a folder, don't include the slash at the end, because then bash says, oh, it's a directory. And you can't remove that directly. Then you will have to force remove and things like this. So the key points. Symbolic links are pointers to another file or directory. There are both soft symbolic links and hard links. They are useful, but for both for the ease and for avoiding renaming and copying files. And you can remove them with either RM or unlink.